All right, well, welcome everyone to Intro to All Weather Window Heat Pumps. You know that there's not often that innovations have come along in the heat pump world. And so we're real excited to be talking about one here today that's going to make it even simpler for heat pumps to get into some areas, existing homes, potentially buildings and other places where they may be unreachable or difficult to. So this is really exciting to me, and I'm hoping you all will learn something new and enjoy this session. Now, before we get started, we want to say a thanks to our supporting sponsor, Tamarack. You know, Tamarack offers a wide variety of home energy saving devices and ventilation systems. They have attic access insulation, air sealing products, fireplace blocks to prevent door air leakage. They have door vents and return air pathways to ensure good airflow if you're trying to get heat pump air from one area to another, maybe. They have whole house fans to keep you cool while saving energy. And as a bonus, they also offer our other sponsor, Panasonic products, all in one place to help you with all of your ventilation needs from exhaust to supply to balance to demand control. Check them out over at www.tamtech.com. All right, again, welcome everyone to Intro to All Weather Heat Pumps. This session is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. Like all of our courses, this course is approved for multiple continuing education units, including three of the pillars, health, materials, and energy, and our certified green home professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license, and you can grab that 5-digit passive house code at the end as long as you're here and approved for the entire CU hour. So with that, I'm super excited to introduce our speaker here, Dr. Vincent Ramanan with Gradient. Vince, please welcome and please take it away.
Hello, everyone. Thank you for coming. Excited to be here to talk to you all. And thank you, Brett, for setting this up and for hosting us. As Brett said, my name is Vince. I work in cold climate window heat pumps. I was part of the invention of a lot of these products and this category. And so I'm really excited to talk to you all today. My talk's really going to focus around history of heat pumps and state of heat pumps, where they are today. Then we're going to go to where we want them to go and what I think the long-term endpoint of heating and cooling, especially heat pumps, should be at. And then I want to talk about how window heat pumps fit into that story, which means where window heat pumps are today and also where I think they're going to evolve in the future. And hopefully with that, we can kind of educate folks on where I see this fitting in, where I hope it fits in the future, and where it's currently fitting in today. So with that, I'll start with state of heat pumps. There is an urgent drive to update our HVAC infrastructure, which is one of the pushes for these new categories to show up. A couple things are involved here. One is aging infrastructure. Heat pumps and buildings are around for a long time. I'm showing a boiler here on the left-hand side. And I think, one of the reasons these are interesting or a problem is they are failing at increasing rates. A lot of older buildings in the Northeast that were built with boilers and radiators have been around for a long time. In New York City specifically, they've seen an increase in complaints to their public heating outage line at about 17% year over year for the past couple years. It's a huge increase. A lot of heating outages when these systems are what people rely on to have heat in the winter. Two, there's looming state and regulatory pressure. Again, New York City's one example of this. They have Local Law 97, which says that buildings need to decarbonize. We've all heard of pushes from state agencies to get us away from natural gas heating toward electric heating. And then three, changing weather patterns often drive system failures and upgrades. We see increased storm surges in winter, increased rain in winter, and we often see increased heat waves in summer. All of these things are driving the fact that our building infrastructure today not always adequate to keep people healthy and comfortable. Heat pumps appear to be the solution to this. Heat pumps are a rapidly growing market segment, especially relative to other parts of HVAC. And so we see heat pump growth year over year. I've certainly heard more about them in the last couple of years, and I assume other folks have too. This is a large sector because heating and cooling of your home is about 55% of home energy use. It's about 70% of home fossil fuel use. And heat pumps can do this at sometimes 3 times the efficiency of traditional systems. So that's a third of the energy of traditional systems. Despite this, we see really slow uptake of heat pumps, especially in older buildings. And often what we hear from customers is steep upfront costs, the time and money it takes to get a heat pump into a building, the complexity of the install in different building types, and then there's often aesthetic considerations. And so we kind of see that there's this infrastructure need to upgrade our HVAC systems somehow. See a lot of talk and tailwinds behind heat pumps, but often when the rubber hits the road on projects, we see a lot of blockers. So before I go further, I want to do a quick poll, get a sense for who's here in the audience and what your experience is with heat pumps so that, I'm not throwing out too many terms that are unhelpful or that I don't spend too long giving background if people here have general understanding or familiarity with heat pumps. And so quick poll, 1 to 5, how much do you know? 1, very little. You've heard the word and that's it. 2, you've used one, maybe paid someone to install it in your home. 3, you know the terms, you know what a BTU is, you know what CFM is, you know what COP is. Like you're technically aware of a lot of the experience of getting a heat pump. 4, maybe you've done some of this yourself. You've done a load calc, you've done an install, something. You've got your hands dirty a little bit. And then 5, you're a pro. Your aunt and uncle call you when you need a heat pump in your home or when it breaks. Your friends call you and they need advice. Maybe this is your job. So just want to get a sense for people's knowledge and understanding here. Doesn't have to be super specific. And we'll see what general knowledge is in the room.
Yeah, we've got about 80% results in. So let's give everyone another 5 seconds. 4, 3, 2, 1. And there you go. You should be able to see the results.
All right, this is a good spread. We do have a couple 5s. That's good. Got a couple 1s. That's good too. But in general, I would say more knowledgeable leaning spread. So I'll try to make sure I give kind of a little bit of context and background on what heat pumps are and what they do. But in general, I assume everyone has a little bit of a working knowledge of what we're talking about here. Great. Thank you again, everyone, for answering. So the next kind of state of the industry problem I want to talk about is what I mentioned earlier, which is in older buildings, you see really a lag. There's not as much heat pump adoption as newer buildings. Part of this is obvious. If you're building a new building, you're probably more likely to consider a heat pump than you were before 1980. 1980 buildings also often don't have ducted infrastructure. It starts to become less common as you get older. And therefore, you need to look more at ductless systems, which are super disruptive to these old buildings. Older buildings are more likely to have asbestos challenges. They're more likely to be in cities where you have maybe a shortage of labor, maybe high labor cost, maybe more regulations around renovating your building. And so these are the things that we have heard drive this lack of penetration in older construction. Also, these older buildings are more likely to have the failing infrastructure that we talked about previously. And part of our approach in thinking and developing, new categories of heat pumps is we should make these where there's the biggest need. And so we see a bigger need in these older buildings that don't have adequate cooling, that have failing heating, and that really should be the first to receive this new technology so that they have more reliable and more comfortable infrastructure. Last thing I'll say is some other technologies that are in this space. Packaged terminal ACs, PTACs are really common. Sometimes the term is used PTHP, packaged terminal heat pump. It looks like a PTAC, but it does heating as well. The best way or most familiar experience people have with PTACs is when you go to a hotel room and there's a big box under your window. This image is a thermal camera image, obviously, from a report called There Are Holes in Our Walls. It is a report put out about the state of PTACs in New York specifically. And it really talks about how these sleeves for PTACs lose a lot of thermal energy and leak a lot of air. And so that's why you see this red box under the window and the thermal image on the right. It's basically saying we've got holes in the facade of all of our buildings to put these sleeve ACs or PTACs in. And the report basically estimated what the energy loss is due to that. And so when you have an older construction building, when you want to put in a heat pump and get rid of the radiator, this is often an approach people take. And the problem with it is it ends up wasting a lot of energy through the hole. Another category of heat pump that's common broadly, but also in older buildings, is VRFs. VRF stands for variable refrigerant flow. In general, most often, people's common experience with VRFs is when you have one box outside and that runs multiple internal terminals. So one outside box that looks like these pictures here, and then maybe one indoor terminal in 3 different rooms. These systems are more likely than PTHPs to be cold climate ready. So when you look for a system that can survive in a cold climate like Michigan or New York, often cold climate heat pumps are VRFs. Um, this is a relatively new technology, and the industry is sort of learning that when you have multiple refrigerant flare joints on the install, you increase the odds that one of them is going to leak. Refrigerant leakage is a problem for any HVAC system that involves a refrigerant connection in the field. And obviously, if you multiply the times of that refrigerant connection multiple times, you multiply the statistical likelihood that you're going to leak refrigerant. The problem with leaked refrigerant is that refrigerant by design is an odorless, colorless gas. And so the way that you notice that you've leaked refrigerant is your performance goes down slowly over the years. And so these systems tend to be more expensive to maintain. They tend to often show in-field performance that is less than what their rated performance is in cases where the refrigerant is leaking slowly. And so people are starting to sort of shy away from these systems because of those performance and maintenance concerns. Not to mention, you can imagine that installing large, heavy boxes and multiple refrigerant line connections throughout the building can be more expensive and increases your labor cost of install. Brett, you have a question?
Can you just spell that word out, VRF, again?
Yeah, VRF stands for variable refrigerant flow. I've also heard for these systems multi-split as opposed to mini-split. I've heard VRV. There's a slight difference between VRF and VRV that I don't have to get into. And it's called variable refrigerant flow because when you have one outdoor box and two, three, four indoor boxes, variable refrigerant flow refers to the fact that you can control those 3 or 4 indoor boxes independently. One can be on high, one can be on low. Some systems you can even have one on heating and cooling. So VRF, not a super descriptive name. Nobody knows why their refrigerant flow needs to vary, but it means one outdoor terminal with multiple indoor terminals.
And have you heard of these systems having the ability to have integrated like energy recovery ventilators or ventilation systems at all?
I'm sure there's some out there. I have not heard of these systems having that. I have heard of package terminal systems having integrated ventilation. I
Mhm.
don't know how many of them have either energy recovery ventilation or heat recovery ventilation as opposed to just ventilation. But with both VRFs and mini splits, most often the pass through the wall is just a pass through for the refrigerant line and condensate line, which means it's not big enough for airflow.
Thank
Mhm. Okay, I've complained a lot about heat pumps. As I do, next, let's talk about where we want them to go. What do we want? We want a couple things. We want them to be better for the climate, but really the customer doesn't care about that. That's not what scales the technology. So we want that, but it can't be the primary driver. So they also need to be better for people. Talk about better for people, it means both the person who's using the system, people's home comfort is super emotional to them. It's very important to them. I fundamentally believe that if heat pumps are not way better products for your home, they will never scale, regardless of any cost or efficiency or mandate. And it also has to be better for the person buying the system, which isn't always the person using it. If you're a homeowner, it's the same. If you're a renter or a multifamily building owner, it's not. And of course, they need to be cost effective and scalable. I've mentioned a lot of the problems with other technologies that are at times limiting the cost effectiveness and the scalability of heat pumps. Okay, what do these things mean? What specifically do we want to accomplish these three goals? Better for climate means efficient. We don't want holes in our walls. We want the efficiency, the rated efficiency of the system to be predictable, reliable over time, and easily verifiable so that after you install your heat pump, we know quickly that it's working properly. You don't want to buy a heat pump and then be surprised by the energy bills. They need to be electric and variable speed. Electrification is a huge way that we make buildings better for the planet. They also need to be variable speed. Most window ACs are still running single speed compressors. Many central ducted ACs are still either single or double or dual speed. It's 2025. We should no longer have bang bang control single speed motors. We have variable speed drives. They exist. HVAC industry is far behind in incorporating them. And variable speed drives give you roughly a 30% energy boost, according to some studies, compared to a fixed speed system. Refrigerant management. If you have a system that is super efficient and cold climate ready and it's fully electrifying your building, but it leaks its refrigerant, that refrigerant leakage is just as bad as burning fossil fuels. If we're going to leak refrigerant everywhere, honestly, we just might as well just burn fossil fuels. You have to fix refrigerant management. Better for people means reliable. I talked a lot about boilers failing often. Everyone has experience of window ACs not working well or their central AC not working. As I said, people's home comfort is important. These things need to be better products, need to be reliable. That also means maintenance cost. You don't want to pay a ton for a heat pump, find out it leaks refrigerant, and then 2 years later have to call a maintenance tech. Networked. There is a lot of advantage of getting data from the system live so that you can verify that it's working properly, so that if something like a refrigerant leak or a maintenance issue is happening, you know immediately and can fix it efficiently. And last, comfort and health. Most systems today are unfortunately designed to hit a temperature, and that's about it. Your thermal comfort in your home is much more than just the temperature of your home. It's the humidity, as you know. It's the radiant temperature of your walls. It's the air quality. It's the particulates in the air and the CO2 in the air. It's how noisy it is. It's the aesthetics. You want natural light through your window. You don't want a window AC. And so as we think about where we want heat pumps to go, we want them to really level up your home. You should get a heat pump and you should not be thinking about the climate impact. You should not be thinking about your energy bills. You should be thinking about how much more comfortable you are in your home after it's installed. Lastly, cost effective and scalable. Lot of challenges with installing PTACs and VRF systems. And frankly, shortage of workforce. It is hard to train people into this job category. We need to figure out how we can get more installers in the field that can put in heat pumps. And we need to figure out how the installation process can be much more quick and scalable. I personally believe modular is the way to go for heat pumps. The more you have a heat pump designed to serve a room rather than a building, the more you can mass produce them and control the quality of that product. Buildings come in many, many different sizes and shapes. Rooms come in fewer different sizes and shapes. Most rooms are between 100 and 500 square feet. Not all. A lot of variation, but you can sort of you can design fewer products that serve a room than you can a full building. Also, people don't use all of their rooms. If you have room by room local control, which central ducted doesn't have, you end up saving about 20% in performance just by virtue of the fact that you don't turn the system on if you're not in the room. We want a system that's compatible with many different building types. We want to cover building types that aren't well served by existing technologies. We want systems that can cover even the coldest climates when you have really cold winters. And last, data driven. We want to be able to control these systems remotely, make sure they're performing well. And another benefit is if we have data coming from these systems, we can better predict when we do a new project how that project is going to perform in terms of capacity and how that project is going to drive energy bill savings. So getting data from these systems is super helpful. This gets us to why I think modular cold climate heat pumps are the future of the industry. They are now capable of running in coldest I think up to climate zone 4, super cold winters, which means down to negative 13 F. They are really, really high performance at these cold temperatures, which means that we're saving, between 3 to 5x the energy use of a resistance heater in heating mode. They often plug into a 120-volt outlet, which means you don't need to call an electrician to get your heat pump done. There's no extra wiring. It's just a standard plug. They can help get through a lot of the regulations driving heat pumps. And they can do a lot of other things. I'm going to talk a little bit about how the airflow of modular heat pumps is improved. It lets you start to do other things that help people's comfort, like MERV 13 air filtration, so that you're not only controlling the temperature and humidity, you're also controlling the air quality. The fact that these systems are fully packaged, which means no refrigerant connections need to be made in the field, means that you don't need a EPA 608 license to put it in. That means that you can train workforce much faster to be able to install these. It also means that install is lower cost. So we can be in and out of our apartments faster. We don't need to disrupt the resident, and we can make that install cost much lower. The install for many of these products, I like to say, is easier than an IKEA couch. From knocking on the door to leaving, probably an hour per system. No holes in the wall so that you don't have to worry about asbestos mitigation. And when they're uninstalled, the window is just as it was before. There's no permanent damage to the building or the facade. Lastly, these package systems have full variable speed, cold climate capable heat pumps directly tied to their Wi-Fi connected thermostats. That means you get a Nest thermostat level quality interface, and also that Nest thermostat has full visibility into system diagnostics, variable speed controls, etc. And so that data connection you get is much more powerful than data connection of a Nest, which just has an on-off, and that opens up a lot of ability to do smarter control of the system. You got a question, Brett?
Yeah, Vince, you mentioned at the beginning and you said it again, so I wanted to come up on the cold climate aspect. Cold climate is sort of a loosely regulated term for now. I know entities are, Energy Star are trying to make that mean something. You've got the DOE challenge from last year that I think, tested systems out in Alaska. You said climate zone 4. So just to be clear, is it systems like these, these window units where they're not being recommended above climate zone 4? Because I certainly know cold climate heat pumps, they're getting into all climate zones.
So I referenced this specific system that's rated down to negative 13F. Really, it's up to the contractor or engineer who's looking at the building to decide. A lot of the older buildings that heat pumps, especially window heat pumps, fit into are in places like New York City. Last time New York City saw negative 6F, I think, was in the 40s, right?
Yeah.
So generally, less than climate zones, what I hear is people saying, like, what is the 1% coldest day that I'm designing for? And what is the capacity that I need at that day? And I think that with the negative 13F lower limit published here, we estimated somewhere north of 95% of the US could be covered.
Mm-hmm. And I know some, different heat pump systems can come with the backup strip heaters in the event to kind of cover that backup, or they have dual fuel systems, of course. Is there any kind of backup system like that?
In many of the window heat pumps that are designed for cold climates, there is not.
Mhm.
Some folks might be aware of a program that New York City Housing Authority ran called Clean Heat for All. It was one of the drivers of, this is obviously New York City Housing Authority is the largest owner of homes in the US. No
Sure.
single entity owns more homes. So Suffice it to say, they put out this challenge to sort of move the industry in a category forward, and it worked because they are they're a big player. And they
Mhm.
specifically said we do not want backup resistance heat.
Yeah.
The reason for that, I'm going to jump ahead a little bit and show the amperage draw of a representative system. At -7F, we're pulling 7 amps. Uh, we are still at that test point getting a COP of about 2, which means you
Mhm.
would need double those amps
Mhm.
if you had a resistance heat. If
Yeah.
you double 7 amps, you get 14, and you are no longer compatible with a regular outlet, and you now need an electrician. You
Yeah.
don't just need an electrician to put the 240 line to that room. You also might need to upgrade your panel to make
Mhm.
sure that the building's total amperage capacity can cover all of those.
Yeah.
And so, really, the driver for Clean Heat for All asking for no backup heat, which is what has driven a lot of products in this category to not have it, is that if you do that, you probably need an electrician and you're probably way increasing the cost. It's actually not the cost of energy, it's the cost of the electrician that makes that backup heat prohibitive.
Sure, sure. And for what it's worth, I for 4 years now, all cold weather heat pump, no backup, no problem. So just to share that with everybody. So thanks.
Mhm. So jumping back up, um, to summarize, we really want heat pumps to be very deployable and scalable. We want to control the quality of the install. We don't want the install process to go poorly because systems are not matched, because ducts are not balanced, because refrigerant's not charged properly. We want it to be fully packaged, deployable, and we want to be able to control that each install is going to work like the last 100 installs. That's why a packaged window heat pump is better. And we also believe it can deliver a significantly better in-home experience. So, you know, I don't like drawing the analogy to window ACs because people see it as very much a budget, low-cost product, whereas I think window heat pumps have the ability to really drive us to a much more premium experience than anything that we see in the industry today. But you have to admire the incredible scalability, installability, and reliability of window ACs. They don't ever need refrigerant recharged. They almost never today, new systems leak refrigerant. And those are the advantages we want to carry over. No refrigerant handling, really deployable and scalable, cost effective because you don't need a lot of labor. But we want the cold climate heating, the zonal control, the advanced capabilities of more professional systems, and that's what window heat pumps offer. Talking a bit about applications. So really today, where we're seeing them most be deployed is, as I mentioned or alluded to before, pre-1980s multifamily construction. It's really a great showcase for the capabilities here because these buildings often have radiators, which means there's no ability to set the temperature for heating in winter in most of them. Uh, the way you control your home's comfort in winter is you open the window in winter to cool off your room because it's too hot. Absolutely insane thing to do from any sort of comfort or efficiency perspective. Also, these old buildings don't have inbuilt AC in almost all cases, which means this product is greatly improving comfort and home experience in both summer and winter. It's increasing the reliability and uptime and capabilities of the building, and it's doing it while avoiding any disruption to the tenants, any upgrades of the electrical system, any asbestos mitigation. Um, it's a really scalable solution for these buildings. We do think that there's a big application for these in single family homes, in ADUs, in renters who want to buy them individually. Even though today it's more often being done for building owners who want to replace their boiler with an electric solution, we think there's a big application here for renters. This could empower someone who's a renter, whose landlord is not going to pay for any upgrade to make their home better. Also today, we most often see these for single or double hung sash windows. I think there's potential for this sector to grow into other window types. And then long term, obviously these systems today are built for cold climates. They're built for older buildings with poor insulation, and they're built to roughly be one per major room. In my opinion, in the future, these need to become smaller and more invisible, When you get to newer construction with better insulation, with newer windows, you probably need half the capacity per room that these systems in these older buildings need. And additionally, if this is built into the window and you have multiple windows per room, you can cut the capacity in half again. So you can imagine that these can get to a point where they're smaller, much more invisible. And as Brett alluded to at the beginning, integrating things like not VRF, ventilation, ERV and HRV, um, light control, maybe they control smart blinds, measuring air quality and controlling air quality, and really leaning into the fact that like these new technologies should focus more holistically on home comfort. They should be better and more comfortable experiences for people. And I think this technology platform is really going to push that forward broadly across the industry, which is why I'm so excited about the long-term potential of window heat pumps. Getting a little more technical, the features of these and how you practically make sure these projects go well, you've got to think about the entire building and the entire system. Obviously, these systems are being used to replace heating systems in very cold winters, and so you have to do something with condensate. You can drip water in a cooling system in the summer. It's an annoyance, but we live with it. If it's below freezing out, those drips would turn into icicles or ice puddles. So you either need a freeze-proof condensate line, which is a complex install and adds more cost to the install. Many of these systems have a way to fully atomize the condensate, which is what we're showing in this video here. It basically turns it into mist so that it just blows away. These are freeze-proof systems that operate in the coldest temperatures, and so it means that it is truly plug and play. You do not need any freeze-proof condensate line to be installed. It will just deal with it. The system still includes a standard condensate drain port if, for whatever reason, the customer wants to install a condensate drain system, but generally the system will just handle condensate without any additional install needed. Another really interesting thing that happens with window heat pumps, the most common architecture is this saddle architecture that I'm showing here. You can look at the heat exchanger here and the breathing area of this system, and it's big. Like this is a larger heat exchanger and more cross-sectional area to breathe than nearly all window ACs, and most PTACs and mini splits. What you get with that big breathing area is higher airflow, which means more efficiency. Some of these systems have a dual outlet design, which means you can point air up or down. That large cross-section for airflow means quieter indoor fan, and it also means you can add air filtration. So you can drop in a MERV 13 filter and start to do air quality control as well. And so airflow really much improved in these systems. It leads to more quiet systems. It leads to better room mixing and better distribution of temperature and therefore comfort, leads to better air quality. There is a major focus in most of these designs in making sure that both the air leakage through the window and the heat conduction through the window is minimized. I talked before about PTACs, which have a large opening, right? You've got a couple feet wide and a couple feet high opening to put a package terminal AC or package terminal heat pump through, and that's very leaky. Here, we're looking at just 2 inches-ish high in the width of the window. And so a lot of design work has gone into making sure that the air leakage and temperature leakage through that pass-through is really minimal. It is much lower than a PTAC. In general, we estimate that it contributes to about a 2 to 3% in the worst case loss to the system's efficiency. So really minor change. In many cases, these buildings have older windows anyway, which are incredibly leaky. And so we're not meaningfully changing that. And in many cases, you can upgrade the window at the same time and get improved performance. Off-the-shelf window locks are readily available. And so since the opening of the window after installation is just a couple inches, no one you can rip out a window AC and break into a home. Can't happen here. The window is locked at a 2-ish inch opening height so that you can't remove the system and break into the home. Unfortunately, we have data to show that you cannot remove the system because someone did try to take one. Commissioning. So, when we started on this journey, we talked to a lot of customers about the performance of their systems. And what we really found that in hindsight isn't surprising, but was surprising at the time, the nameplate efficiency is not what is driving a lot of the existing energy use of systems. A lot of it is the way the systems are designed and installed and the way people use them. The human interaction to actual energy use is huge, and the installer and maintenance interaction to actual energy use is huge. The advantage of a fully packaged system with minimal on-site configuration is that you don't need to worry about duct balancing or sizing the right air filter or any of the other human interaction. You really make sure that the quality of the install is very consistent and as designed. End of life also becomes easier. Because there's no field connection or refrigerant line, we greatly reduce the potential for leaks of refrigerant. And also at end of life, it's easy to remove. You do not need to do refrigerant disposal on site to decommission the system. It can be sent to a recycling facility as any window AC can. And because we are not modifying the building, because we're using existing 120 volt electrical plugs, it is much easier for code compliance.
On the end of life use, is there product take back, recyclability? Is this something you're looking into? Like what happens to these systems?
So we as a company are working on some of these programs. We don't have anything public to share yet, but I think broadly talking about the category of products, they play much more well with these systems because there's a lot of existing infrastructure already for packaged AC recycling.
Mhm. As far as the code goes, you mentioned there, wouldn't a code official see that there's no heating system and start to question, hey, there's no heating system in this building. I need to see what's going on. Like, how would that work? The AC, I understand, right? But they're probably going to be looking for a heating system.
Yeah. So often we do need to work with a code official to be able to, sorry, I shouldn't say we, the building contractor, the engineer, the
Sure.
person who's doing the full building project that's using a window heat pump product needs to consider these things. I'm mostly referring to the code needed to, for example, physically mount a mini split on the outside of a building. Um, but you do need to make sure that this building has enough capacity. You can't just decommission a boiler and not replace it with a system that doesn't have equivalent capacity. So sometimes that shows up, but we do streamline a lot of the code compliance because you can drop it in like you can a window AC. Fitting into that sort of category of product enables a lot easier install.
Do you know if any codes in the country are getting updated or rewritten to include these systems, or is the International Code Council including them at all in there?
I'm not sure about the International Code Council in places like New York specifically, where you see a
Yeah.
lot more regulations around what buildings can do because it's a very dense city. New York Housing Authority leading the way with this cold climate challenge really like sent a message to other city departments that like, hey, this is something that the city needs.
Yeah.
And so that has helped pave the way, and other cities have seen that. And so generally, when we've talked to agencies that have oversight into these types of products, they've given us the thumbs up pretty easily because um, they see the benefits and they see that a lot of these major players are doing it. We have worked very closely with Department of Energy and other organizations like the Consortium for Energy Efficiency to develop new categories and testing standards for these products. I think that's super important that there's like established test standard understanding of the product to build confidence. Um, but you're right that it does really depend on the specific building code official, especially when you get to the point of decommissioning a boiler. It depends on the local regulations, and we've worked with a lot of those local bodies to make sure everyone is understanding of the product. I'll also say the thing that makes this easier is these are modular and deployable. So sometimes you talk to customers who say like, hey, I want to get rid of my boiler, but I want to do it in 2 years. So I want to install a couple systems, 5%, 10%, try it out, see how it works, make sure that the residents are comfortable and they like it. You don't have to fully remove the boiler to do the first couple systems. You can install all systems and keep the boiler in there. You can run it for a while and make sure it's doing what you need. If you put in 2 systems in your apartment and you think you need a third, you can do that. You put in 3 and you decide it's too many, you can remove one. It really helps get through the commissioning process in a really flexible way because you can stage them and you can run this in parallel with a heating system as long as you want. We're happy to these products work well with hybrid buildings. The building owner wants to go hybrid. Um, Before we talk about efficiency ratings, quick definition. HVAC industry has not always been great about the terms and naming they use for things. And so SEER is the combined energy efficiency ratio. It's different than the other SEER, which is spelled with an S, SEER, seasonal energy efficiency ratio. But you can roughly correlate. It's not actually exactly one-to-one, SEER to SEER. But this is the rating system used for this category, CEER. This is a comparison of one product, CR 16.8, to how it would translate to a CR2, which is what a mini split would be rated at. And then there's here, heating energy efficiency ratio. This is the equivalent heating performance. Again, HSPF is already in existence for mini splits. Unfortunately, these products are not rated to an equivalent HSPF rating. They have their different efficiency, which is here. A little bit easier to translate from here to an HSPF. And so I'm introducing that here. So here, HEER, heating efficiency of this product category. SEER is the cooling efficiency. Here's an example spec sheet. Important thing to call out here is the capacity and the COP at lower temperatures. Place like New York City, often 17F might be the design temperature. And so they're looking at what is the capacity at 17F and can it meet my building's needs? Here you can see the capacity that we're rating, that this spec sheet is rated at is 9,000 BTU per hour. You maintain 100% of that capacity at 17F. Also, you're at 2.4 almost COP at that lower temperature. And it's that lower COP that really makes sure that you can work with the existing building electrical infrastructure as much as possible. Consortium for Energy Efficiency published their new specification and new tiers. This is a rating program that lists, what is tier 1, sort of base efficiency, tier 2, better efficiency, advanced tier, which is the highest efficiency. They said that to get their advanced tier for a room heat pump, which is the name of the category, it needs a 15.1 SEER in cooling, an 8.5 here. It needs a COP at 5 degrees of at least 1.75, and it needs a capacity ratio from 5F to 47F, about 70%. So really just putting this here to, this is the first agency to publish these tiers. This is what's expected of these systems in advanced tier when they're ready for cold climates. And the fact that they publish this helps because now there is a third-party body who is sort of putting their stamp on products that they claim are very efficient, which helps incentive programs and people understand that this is a real category and that it's going to perform as they expect. Currently, there's one product on the advanced tier list. You can go to CE's website and see it. And so excited to see this category grow. Amperage draw is often a common question. People are very concerned as they switch to heat pumps. Is their electrical system going to handle it? So listing here approximate current draw at capacities. Obviously, it varies based on a lot of things, but you can see that the capacity is looking, it's not a ton of amps. Almost all of these systems, I believe all of them that I'm aware of, have variable speed compressors in them. Fixed speed induction motors in compressors, which is what's most common in window ACs, have a very spiky startup current. So when a window AC trips the breaker, it's usually that startup current. When you see that current spike on initiation, that is what's killing the breaker. These variable speed systems have two advantages. One, they don't have that startup spike because they're variable speed drives. Two, they're more efficient. So their constant or average current draw is much lower. And so having this low current draw is really important for as much as possible limiting electrical upgrades. Okay, quickly I'll go through case studies and then we'll save some time at the end for questions. I've talked a lot about why this category is important, where it's going. What have we done? What's working, what's not? Clean Heat for All Challenge that I mentioned was put on by New York Housing Authority. The program was run in conjunction with NYPA, New York Power Authority, and NYSERDA, New York State Energy Research and Development Agency. Sorry for so many acronyms. And they ran a study. They said, we're going to run this program and we're going to publish the data because we want the full industry to move forward in this category. We want this to be an established category that everyone can use, not just us. And the key research questions were the four obvious questions. One, does it heat through winter? New York City gets cold. Is this product really going to cover all of the capacity Are residents going to be happy through winter? Two, what does the install look like? Can it actually be scalable? Can we train our maintenance staff with no HVAC experience to do this? Is it going to ruin the building, et cetera? Three, what's the amperage draw and can our electrical system handle it? Is it going to change our peak demand meaningfully? Is it going to change our heating bills meaningfully? And four, are residents comfortable and happy? New York did this program in a way that, really wanted to push forward the sustainability of their infrastructure, really wanted to push forward the industry, but they knew that the primary goal is residents need to be comfortable. These buildings often see boiler failures and heat outages in winter. They do not have cooling currently, and they had one summer where heating was so high they had to figure out how to get more ACs in the building because they don't want vulnerable populations to suffer the health effects of heat waves. So they really did say, like, hey, this is a public health issue. We need to make sure residents like this. The pilot study was run on 24 apartment units that have about 3 heat pumps each apartment, which means 72 total window heat pumps. It's a 2-bedroom apartment. 3 heat pumps means 1 in each bedroom and 1 in the main room. They did measure if the kitchen and bathroom, the smaller rooms without heat pumps, were comfortable. And there was no additional heating. The steam risers were turned off for all apartments. So no backup heating, no steam heat bleeding from the riser or from neighboring apartments, only heat pumps. They saved 85 to 88% of the heating energy. That's massive. That is what we frankly expected based on the roughly 60 to 80% efficiency of the boiler, based on the roughly 20% savings we estimated from not overheating the building. As I mentioned, if you have a radiator, your thermostat is opening the window. Maybe another 10 to 20% for having local control and not heating or cooling the whole building, but having a terminal in each room. You add that up, you'd expect to reduce the energy use by 85% or more, and that's actually what we measured. So really, really happy to see that, like, the spec sheet, the analysis that we showed is being demonstrated in the field. That means a cost savings of about 50% in heating energy bills. Electrons are more expensive than molecules, and so that energy savings is a little bit lower in cost savings, but still demonstrating a 50% lower energy bill from this product is really great, especially for the heat pump industry. Like I said earlier, you don't want people to install these and have a higher energy bill, so really happy with that. We estimate this is about a 76 to 80% reduction in emissions. No temperature distribution issues. The bathrooms and kitchen were comfortable all year. And they only saw a 30% increase in building load from heat pumps. So really minimal increase in the electrical load, which was really great to see. So in addition to being lower cost to install, they were lower cost to operate, they were more comfortable for the residents, and they were better for the planet. Like, you don't often get all three. And so really, really happy with the results here. I think it was big to show that window heat pumps are a great way to replace fossil fuels, to win on the environment, to win on reliability of infrastructure, and to win on resident comfort. Talking a little bit more about residents, we saw really high satisfaction. The survey, I think, showed 89% were satisfied or neutral. Sorry, 85% were very satisfied, 11% were neutral. No one was dissatisfied. Biggest thing, people said, I can finally control my temperature in winter. People were super happy about that. It looks nicer. They can open their window, they get natural light. There's a shelf in front of one of these systems at least. And so it really focuses people to look out the window, put a picture on their shelf and bring an elevated experience to their home. A couple more quotes. I think the press were really excited about this project as well. You can see a couple of the residents here super happy with their new systems. That's all I had. I know I went a little bit late. I can stay a couple minutes over, but thank you all for joining. Again, my name is Vince. I'm here with our Senior Manager of Business Development, John Lusk. We're both happy to answer any questions. You can reach out to us. I'm very findable on social media, and our email address is here as well.
Yeah, thank you so much, Vince. Let's get into some of the questions that we have. And before we get into those questions, just a real quick reminder that the answer is yes, this session is being recorded. It'll be available on our YouTube channel probably in the next week or so. But you can head there, you can check back there then, or you can head there right now, click subscribe, turn on your notifications, and you will receive an instant update when the session is available. If you want to re-watch it, share it with friends, colleagues, you name it. For those of you looking for your continuing education units, if you're watching this in the future, not right now, but on demand, take your quiz with an 80% passing rate on whichever system you're watching this on. If you're here today live, as long as you were here for the entire CEU approved hour from the start till now, and you take that survey that pops up or is emailed to you, you will receive your certificate from certs@gutenbergcerts.com. Check your spam. You can also log into your account to access there. And make sure to take that survey because we want to hear your feedback as well. And again, before we get into those questions, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reina, our over 400 members. We're trying to get to 500 in celebration of our 25-year anniversary this year. So help us get there. And our top tier sponsors who are making products like Ream for heat pump water heaters, Build Equinox for demand controlled ventilation, and many others who have products that are going to help you decarbonize and make more sustainable products. So yeah, there was a lot of kind of chatter and question here just about the windows. So I'm gonna kind of capture it all into one and then kind of let you, Vince, kind of answer it how you want. But on the existing housing side, there was just commentary about, windows potentially needing to be expanded, maybe at least in their opinion from looking at it, or, seeing, certain types of windows wouldn't work well for this. There was concern about air leakage, in the windows when you put these in, air loss or even thermal bridging, heat transmission loss. And then for new construction, the thought was, the whole idea is that we want to try to build more towards the passive house system. So we're trying to keep all of our mechanicals inside and potentially using types of windows that don't work for this. So could you just kind of respond a little bit to some of the challenges and opportunities with, new and existing window systems?
Of course. As I said, long term, I absolutely see different form factors that more invisible, sit differently, work with different window types. Um, Today, about 60%, according to the data we have of our window stock, is vertical up and down opening sash windows. We estimate that we're compatible with about 80% of those windows, which means we started this out saying, one, what is the sector that most needs this system, older multifamily? And two, how can we design for as much of the market as possible with one SKU? And that answer was this type of window in these dimensions. As I mentioned, we're compatible with about 50% of rooms. And that's huge. There's not many other HVAC products that have such wide compatibility today. But you're absolutely right that in the future, we want to work with new construction. We want to work with passive house standard with casement windows and different types of windows. These will require more modifications and different design. This was really the biggest section of the market with an intro product that also addressed the biggest need of HVAC upgrades. The air leakage was measured as part of this M&V study that I mentioned. 4 out of 7 windows were better after installing. That's more a testament to the leakiness of the window that was already there than our system. And as I mentioned, you can install a new window with the system. That is totally fine. And you can really fix the gaps of the previous window when you do so. Both the air leakage and the heat leakage of our system install was measured, and it was about 2 to 3% of the total system's efficiency, which is really minimal. So we've done a lot of work to design the installation system to make sure you can cover all gaps for different window geometries, to make sure that the ceiling is as insulative as possible so that there's not conduction through, and that you minimize that air leakage. And we've done that successfully and shown in the field that it is a very minimal impact on the performance effect of the system. 2 to 3% loss in some windows is totally fine when you're saving 85% from the previous system.
Um, Now, what about how do these window systems track with these window heat pump systems track with the incentives available? So just the other week we did a sort of an update on where we're at with all the Inflation Reduction Act
Hmm.
incentives and rebates, and of course there's a lot of questions up in the air. So of course you have your state homes rebates, which some states have, and there are different areas. You have your general 25C individual tax credits, and then you have your more business multifamily oriented tax credits, which are based on energy modeling like 45L, 179D. So just, I guess, are these systems included in a lot of those incentives, or are they excluded, or does work need to be done there?
So we've done work since the beginning alongside of other manufacturers, alongside of NYCHA, NYSERDA, and NYPA when they ran this Clean Heat for All program, with federal agencies and state agencies to get qualification for this new product category. That work directly led to the new HERE standard that I mentioned.
Mhm.
It also directly led to the Consortium for Energy Efficiency being publishing these tiers for room heat pumps. Um, this is the list that 25C tax credits refer to. And so because we are listed here, we are eligible for the 25C tax credit. Some other programs require different standards or lists or need to incorporate this into their programs. And
Mhm.
so we work directly with those programs to make sure they're qualified. Obviously, there is a lot of uncertainty around some of the federal programs, but many of the heat pump programs are either state or utility run.
Mhm.
And so we're not just working with federal government, we're working with state and utilities to make sure that this is written into their programs. Many of them do have specific language written in that allows for their programs to be applied to room heat pumps, and many more are coming.
There was a question here about aesthetics. Now, of course, when we think of our heat pump friends, we think of, your traditional mini split. It's kind of sticking out at the wall at you. Not always so great looking. So the very specific question here was, can you put flowers or other items on the top of the outside for unit beautification? And they said it looks like there's no lip, so items could slide right off. Just a thought. So, Ben, any thoughts on that?
Yeah, we actually did think about if you can put like a planter box on the outside.
Yeah.
Uh, something I frankly love people to do. Generally, building owners have not wanted that, they don't want that part to be a shelf. Like I think it introduces a lot of liability and risk.
Yeah.
We do want the inside to be a shelf. There is a lip on it purposefully for that. And the purpose of that is obvious. We want people to think of, we don't want them to think of what the system looks like. Want them to think of looking out their window, putting a picture frame on it, putting a plant on it. So we definitely do encourage people to use the indoor side as a shelf. I think it's gonna be a little more work before we can ensure the safety of using the outdoor as a shelf. So there's no plan for that currently. It is super safe. Again, when someone tried to steal the system, they had a couple people sitting on it. It's designed to be, oh, it's designed to be hurricane proof. And unfortunately, we do have data to show that that's true.
Mhm.
We had a system survive a hurricane. So the outside is super stable and safe. Unfortunately, it's not a shelf yet. Inside, it's a shelf.
Mhm. Um, uh, do you have time for one more quick question?
Yes, I can go
Yeah.
late.
Yeah. So one of the other questions was sound. We think about the green building programs. Of course, we want to, when we think of health, we think of more than air quality, we think of sound impact. And so we measure sound in homes, and that sound can come from many different places, especially in multifamily. So
Mhm.
what kind of, decibels are being put off by these types of systems, both on the inside and on the outside?
So you can go to our website to see our sound ratings.
Mhm.
I'll caveat that with, we've tested multiple systems in our sound chambers with different published sound ratings and seen live experiences that are very different than that sound rating. There's a
Mhm.
little bit of a lack of standards around the sound rating. Not to mention the decibel rating is not the only thing that affects the quality of sound. It's the tonality. There's, a lot
Sure.
of subjective experience of this. It's how abruptly the sound comes in and
Right.
out.
Right.
We've done as much as possible to design our sound experience to be smooth. So any system transitions, the way that that system transitions, it considers like how does the sound both say something to the user they don't want it to say, and how is it the most pleasurable transition as possible. And of course, quietness. The large cross section for airflow you see here means lower fan speeds, which for the same airflow rate, which means lower noise. And lastly, the saddle means the compressor and the outdoor fan are outside, similar to a mini split, better than a PTAC, which helps you isolate sound better. The window sealing is, of course, primarily for energy use, but also is done to make sure you isolate sound. What all of this means is that it's a really good sound experience, especially compared to competing systems. We end up being about, a similar quietness to a mini split, much better than a PTAC. Radiators clank all the time. Window ACs are super loud. So, um, hard to give a single sound rating that really describes all of that, but anyone's welcome to see us in person. We've got demos on both coasts, which isn't everywhere yet, but you can listen to it. It's really quiet. It's a nice experience.
Yeah. Um, another aspect of green building is resiliency to the changing climate and things getting worse. So the specific question in here came in from, someone in climate zone 2, concerned about the impact of heavy winds, hurricanes on these, tornadoes. I think here in West Michigan, anytime we do our climate risk evaluations to building, wind is our number one threat, like this, the straight line winds. They keep hitting things, they degrade the building. So how do these systems stand up against that?
So we have designed for hurricane force winds. I do not remember exactly what hurricane force winds meant in that design, but
Mhm.
we've got a very sturdy install bracket on this system. Obviously, I can't speak to all systems, but
Mm.
we have done analysis to make sure that it can handle super strong force winds. We did have a system in Florida about a year ago for the hurricanes that it saw. System was fully submerged in water. No damage to the install bracket from the winds from that hurricane. I don't know exactly how high they were, but definitely welcome you to reach out and we can talk through what wind loads you're going to be seeing. I'm confident in our system, and we can talk specifically about what data we have to show that that's stable. But we really made sure that the bracket and the security of the system was designed. If these are going into multifamily buildings, you can't risk anything ever going wrong over the full life of the system.
Mm. Another question that came in was about the system heat, the question is, does the system heat the water condensate indoors to prevent the mist from becoming a freezing fog in very cold climates?
It does not heat it indoors. The condensate is pumped to the outdoor where it is then atomized. The atomization system is far enough from the window that we have not seen any problems of it um, freezing on other surfaces. In general, it is dispersed fast enough, especially with the open air outside, that we haven't seen an issue on that. And so it was specifically designed with a kind of physical distribution and geometry and velocity to make sure that it gets away from the building and disperses before it ever collects. And we've seen that to be true in the field.
Um, so that question is, will these need or are they better to have dedicated circuits, or does it not matter at all? So if we're installing these in bedrooms, are there possibilities of overloading the circuit breaker?
So that is a question I think that we usually defer to the building engineer or designer. We've got our amperage ratings published, and we let the electrician decide if they want to put this on a dedicated circuit. But generally, we're lower amperage than whatever window AC is there before, and so that ends up being a good proxy. Um, but it's really up to the electrician to determine that. We can't determine that. We just publish our amperage rating.
Mhm. There was a question about your chart that you were showing for the current draw, showing at least somebody had said it was lower at -7 than it was at 17 degrees Fahrenheit. So they were just wondering why, or did they see that correctly?
You did see that correctly. It's primarily because of less capacity. The capacity that amperage was listed at was the um, max capacity listed at that temperature. Our capacity is 9,000 BTU at 47F, 9,000 BTU at 17F, and then a lower, I think, seven something BTU at 5 or -5. So anyway, I can pull back up what I listed, but the reason for the lower amperage draw is the lower capacity at that colder temperature.
Um, And the other question just was, can the thermostat limits be pre-programmed for the thermostat?
They will be soon. We work generally with a customer and the building owner to make sure that the project meets what they need. We've had some customers long-term request this, but we haven't done any projects where we've implemented it yet. But the system has the ability to work with the building owner's building management system. If a project owner needs that, we can make it happen for that project, but it hasn't been done on any existing project yet that I know of.
Um, so with the announcement of the new refrigerant requirements, I think going into place for anything that uses refrigerant, and then of course the recent announcement of the rollback of those requirements, where do window heat pumps stand in that sort of update? Are they moving forward with these new refrigerants or that I believe are supposed to have lower global warming potential?
This is a hot button issue for me. I can give another one of these for 2 hours on refrigerants.
Yeah.
I'm going to save my philosophical and long-term questions about what I believe our regulatory strategy should be around refrigerants. And I'll just answer specifically for window
Yeah.
heat pumps. Because they're fully sealed and you don't need to commission on site, you do not need to worry about the future availability of refrigerants. So it is a problem for us as manufacturers to make sure our system is designed and built compatible with existing regulations and requirements. The customer does not need to worry. There's never a situation where they're going to be like, am I going to be able to recharge the system in 5 years? Because you don't need to recharge the system. It's install and forget it. None of the technicians or maintenance people ever need to touch the refrigerant system. However, how we make sure that our emissions are low from refrigerant, we today use R32. We use less charge than most systems because we're fully packaged. We don't have long line sets. And we expect leakage to be much, much lower because it's sealed and no field connections. And so we think a lot about how we can design a system to minimize the refrigerant's environmental impact. With R32, with our leakage rate, our charge rate, we expect to be about 95% lower refrigerant emissions than a split system with R410A. And we're really proud of that reduction. We want that last 5%. And like I said, I'll save my long-term refrigerant rant for later, but we believe R32 gets us a huge, huge step forward.
And just as a reminder, R32 is the new refrigerant that everything was moving towards, correct?
You
I
know,
know there's yeah.
yeah, I hope it's the new refrigerant. I don't know if that is I don't know if it is fully determined yet that that is the new refrigerant that
Sure.
everyone is moving toward.
Right.
I certainly do hope it's for the next phase, the main refrigerant. I don't think there's going to be just one, and I think long term we need to get to CO2 and R290 for everything.
Right.
Not happening this year.
Right. And that's what I was going to ask is, yeah, about the CO2. I mean, being the inevitable, and if you see that window,
Yeah.
heat pumps can do that
I
someday.
saw I saw a heart go up. Thank you for that. Huge
Yeah.
fan of R290 and
Yeah.
CO2. I think most heat pumps are going to use in residential applications are going to use R290, and I think water heating systems will use CO2 because of the different performance levels of those two.
Yeah. Yeah.
Like I said, there's going to be a couple. I think those two should be the main ones long term. Most of the
Yeah.
rest of the world is already there, frankly, right?
Yeah.
Like Europe and Asia have been making big moves toward R290. We're not there yet in North America, but
Yeah.
that's another battle to fight.
Yeah. And I think just on that question of sort of the future look is someone was asking, what are the expected life expectancy of these systems?
Um, all of the components they use are industry standard
Mhm.
components that have 10 to 15 year lifespans.
Yeah.
And in fact, we remove a lot of the potential for failure by removing refrigerant leakage potential. Refrigerant leakage potential doesn't just hurt your performance, it can damage internal components. And so,
Sure.
um, we haven't been around to have the 10 to 15 year data, but it is
Yeah.
designed for that. We have accelerated life testing that shows that these systems should be longer life and more reliable.
Okay. And so you have the ability you mentioned to upgrade to MERV 13, which is great for filtration. What do you recommend in tandem with systems like this for ventilation, or is that really just a sort of separate, matter? And the reason I kind of ask is if you have a larger unit maybe, and you're trying to get that warmer air to move into other areas of, the house or the apartment, are there ventilation strategies that might serve that better? Is that something you think through at all?
Yeah. So the answer for ventilation with external air is twofold. Today, we work with the contractor, architect, building designer, whoever it is, to figure out the right strategy that pairs with our system.
Yeah.
Long term, I do think that window heat pumps as a category will start to include HRV, ERV. It's something we're looking at.
Hmm.
It's not there today, but long term, the passage through the window is enough area to do that. So that the install is the same, system looks the same, and you're adding new capabilities without any additional install labor, which is something I'm excited about the category for. For ventilation to move air within a home to cover smaller rooms. Typically, what we do is we measure first to see if it's needed. It's another nice thing about the modular nature of the system and the reporting of the system remotely. We can get our temperature data reported remotely and put other sensors to match with that. We haven't seen it needed, but we check. This was a specific thing in NYCHA. We said, are the bathrooms and kitchens comfortable? And they tracked pretty closely. So we haven't seen it needed there. Some apartments might have weird layouts where, it's not as easy to distribute air. We would measure and check. And if you needed to do, one of the sponsors today builds systems that can do this. You can add ventilation within the home to make sure that distribution happens. And the dual vent design we have in our system has helped a lot with room mixing. The top vent is closable, the bottom vent is not, because most often what people want is in heating mode to only have bottom vent. In cooling mode, they're fine with both. And so that we found that to help a lot with temperature mixing in the room and home.
Mhm. Mhm. Um, so when we think of the green building programs, we also look at pest management, trying to keep pests out and use a lot of strategies for that. So the question here came up, is there a possibility of insect nesting? They mentioned, wasp love cavities in Canada, probably here too in the US. And so in the condensate misting holes, is there a blowout feature to clear of any obstructions? Or what is your, overall approach to pests at all, or what issues do you see?
Sure. Haven't seen issues yet. We have designed for this and tried to cover as many situations as possible. The window ceiling specifically has in almost all of it hard plastic covers. And so the seal is never just a large foam area. There's some areas that you have to cover with certain amounts of foam and tape, but the horizontal space on either side of the window is hard plastic for that reason. We have not yet seen any nesting or issues with the atomizer. The hole size in them is micron scale. And so we don't believe it's a place where they could get into. And so any, the outdoor system it looks like a mini split outdoor system. I don't think there's going to be any difference than that. So if you have problems with mini splits being, having pests in them, you probably have to use the same mitigation strategies on ours, but nothing new. Hard plastic seal in the window and no additional like areas for them to go than competing systems.
Mhm. Um, Speaking of the plastic, there was just kind of a question is if there's, you know, other models that might have less thickness, less bulkiness. Is that, I mean, kind of a dematerialization or anything?
We think eventually like we will look at different form factors. We've really, really focused on minimizing the window opening and minimizing
Mm.
the depth into the room. Those are the
Mm.
two most important dimensions for space. We
Yeah.
found that having one SKU that covers as much of the building stock and as much of the climates as possible is important. And we found that a
Mm.
variable speed, 9,000 BTU per hour at that 17F temperature is that sweet spot for one SKU, especially for retrofit. But in new construction, as I mentioned previously, you probably want about half that capacity if your building's really well sealed and insulated. And then if you can have multiple systems or one system in each window, your bigger rooms probably have multiple windows. So you really have a lot of space to look at smaller systems. Um, and so that is something I think really interesting for the future of this product category. Today,
Mhm.
just one SKU.
Yeah. And on the note of materials and all that, I know typically the mechanical systems get excluded when we look at embodied carbon calculations that are becoming more and more important for, especially for new construction, but also for existing. But we are seeing more MEPs adding in the EPDs, the environmental product declarations, Is that something that window heat pumps will have come along with it to show what their carbon impact is?
I hope they do eventually. Honestly, right now we are focused on the 80/20 approach. There's a couple of pretty big elephants in the room that we want to get through.
Sure.
We've done the napkin sketch on what our embodied carbon is, and it is The conclusion of that is not something that is important to spend time on now.
Right.
Three biggest kind of things you've got to solve are electrification, stopping leaking methane,
Hmm.
and stopping leaking refrigerant. If you do those three things, you cover such a huge percentage of the carbon in this sector. And so
Yeah.
that's what we've really focused on. Long term, absolutely right. That's something we want to look at. Um, and we think that's helpful for getting kind of like the refrigerant. We're 95% of the way there. We're not going to focus on the 5% yet. We're going to deploy the 95%. Long term, we are going to look at that as well.
Yeah. And are window heat pumps only available in the US? Are they expanding into Canada or other markets? And I mean, are there any certain policy things that may be coming that could otherwise, slow that down?
I don't think that there's policy that would slow it down.
Yeah.
Luckily, again, I think we've really thought about this from the start to be as deployable as possible, which means like looking at what we think any roadblockers are around permitting or whatever. Canada, we are not available there today, but I don't want to announce anything before it's ready. I'll just say call us and we'll talk about
Yeah.
projects. We are very much looking at expanding to, as many areas that need this product as possible. Today, we are only available in the US, but we still would appreciate any outreach for anyone who's interested, and
Okay.
we can talk about timelines.
Yeah. Great. Well, we are at our time here, Vince, and I really appreciate you sticking around a little bit longer to help answer some further questions and for doing this. I guess just as a reminder, where can people go to reach out or learn more if they want to find out more?
Sure. Sales email is here. That is the best place to go for a quick response on specific project details. I'm very available and findable on the internet, LinkedIn. Our website has contact information as well, radiantcomfort.com. So yeah, reach out to myself or John. He's probably more responsive than me. Me and John, sales email, LinkedIn, website, all good places.
Yeah. All right, great. Well, Vince, thank you, John, thank you, and Gradient for coming out and educating us. Really appreciate your time. Thank you all for joining us. We will be off next week for spring break, but we'll see you again in 2 weeks, everyone. So take care. Be well. Thank you.
Thank you for having us, Brett. Thank you, everyone, for listening in and for staying over as I answered questions. It was great to chat with you all.
All right. Goodbye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.